Hello students, and welcome to today's lesson on equivalent and non-equivalent ratios. As an intro, I want you to look at these words. What do you notice about the end or the base word of non-equivalent? It has the word equivalent in it. You know that the prefix non means not. So in today's lesson, we are going to be looking at opposites, equivalent and non-equivalent. For our essential questions, we will be reviewing this essential question because we will be using ratios within this lesson. But our focus is going to be, what is a proportion? Is every pair of ratios either equivalent or non-equivalent? And the answer is yes. So what we are going to work on is determining how we can decide if they are equivalent or non-equivalent, and we will learn that in two ways. So what does the word equivalent mean anyway? Let's talk money. Let's say you have a dime and 5 pennies. Someone else has a dime and a nickel. If you were to compare your two amounts, you would say they are equal in value. Yes, this person on the left has more coins, but the person on the right's coin, the nickel, has more value than one of this person's coins, the pennies. The dimes are the same, and 5 pennies is equal in value to this nickel. So these two people have amounts of money that are equal in value, and that's precisely what equivalent means. Equivalent does not mean the same. It doesn't mean that you have the same exact numbers or same exact individual values, but it means that you are equal in value. What one ratio says is equivalent, is equal in value to the other ratio, just like these amounts of money were equal in value. So if equivalent means equal in value, what does non-equivalent mean? I want you to think about this pizza and this pizza. If I gave this one to you and this one to your friend, you would say that that is not fair because they're not equal in value. So non-equivalent means not equal in value. We know that this fraction, which is a type of ratio, which is 1/2, is not equal to the other ratio, which is 3/4. So if we wanted to write that, we would say 1/2 does not equal 3/4. This is a symbol that means not equal. So I want you to look at this ratio. There are 5 teachers for 35 students. But if I only look at 3 teachers, there's 21 students. Would this represent an equivalent or a non-equivalent ratio? Well, in the last lesson, we learned that if we want to compare these, we need to get either the top part of the ratio, the first value in the ratio, or the second amount in the ratio to equal the same amount. What could we look at in terms of teachers and students that could be the same? I think it would be wise to look at how many students one teacher has. If we're going from 5 to 1, we are reducing the ratio. We will need to reduce it by 5. Split it into 5 groups. We will likewise need to split the 35 students into 5 groups. So if we reduce the number of teachers by 5 to get 1 teacher in each group, and we reduce the number of students by 5, we would get 7 students. Each teacher would have 7 students. This is an equivalent ratio to this. Now, if we want to do the same for the second ratio to see if we get the same ratio, the same consistency, we would have to reduce this ratio by 3 to get 1 teacher. 3 teachers divided by 3 makes 1 teacher. We would likewise need to split the students 3 ways, which would create a group of 7 students, because 21 divided by 3 is 7. So you can see that these two ratios are equal in value because their reduced ratios are the same. So indeed, these are equivalent or equal in value. 2 equal ratios are called a proportion. So a synonym for the word equivalent is proportion. If 2 ratios are a proportion, we can use a suffix to say they are proportional. So let's look at these 2 ratios. Now, I know that you know a half and 2/4 are the same, but I would like to look at different qualities. Most of you can visualize that if you expanded a half by 2, it would be the same as 2/4. So one way that we can determine if ratios are equivalent or non-equivalent is to expand to get a common number, which would be the denominators or the numerators. Another way, some of you may have visualized, is to reduce this ratio by 2 to get 1/2. So our second option is to reduce. Now, the third option gives us more flexibility. I want you to notice what 1 times 4 is equal to. What's 1 times 4? 1 times 4 is 4. And I want you to notice what 2 times 2 is equal to. 2 times 2 is 4. If 2 ratios are equal, then their cross products will be equal as well. So our third option is to check cross products to determine if they are equal in value or not. If the cross products are equal, then the ratios are equal. So when we're determining equivalent or non-equivalent, there are 2 ways to determine this. The first is to reduce the ratios to simplest form to determine if they were equal in value. This also encompasses expanding. Reducing is just the written way that you can do it, but you can expand it too. Or calculate the ratios cross products. If 2 ratios are equivalent, then their cross products will be equal. And the opposite is true. If 2 ratios are not equivalent, then their cross products will not be equal. Both of these have benefits. Reducing is often easiest if you can quickly see a common factor. If you cannot quickly see a common factor, checking the cross products may be a faster and more effective way of determining if something is equivalent or non-equivalent. For example, for this one, you can reduce the ratios if you want to, but you could also cross multiply. And I like cross multiplication on this one because it has a decimal. And most of you do not like to divide decimals, so this makes it a little easier for you. 1.5 times 20, 1.5 times 20, we do not need to multiply the 0, we just need to use it as a placeholder. 2 times 5 is 10, 1 times 2 is 1, and 1 more is 3, so we get 30. Some of you could also visualize that. One set of 20 would be 20, half a set of 20 would be 10, so that makes 30. Either way, you can do it on the side of your paper or mental math there with that multiplication. 1 times 32 is 32. 32 does not equal 30, so these two ratios are non-equivalent. They are not equal in value. Why? Because their cross products are not equal in value. Now, this ratio, in my opinion, is easier to reduce because I see that 3 is a factor of 9. I could reduce the number of boys in this ratio to be 3 by dividing by 3. If I take the 27 girls and split them 3 ways, I would get 9 girls for every, and 9 boys divided into 3 groups would make 3 boys. So is 9 girls for every 3 boys equivalent to 1 girl for every 3 boys? And the answer is no, they are not equivalent. You could also cross multiply 27 times 3. 3 times 7 is 21. 3 times 2 is 6, and 2 more is 8. So we get 81. And 1 times 9 makes 9. So again, this is another way to prove that they are not equivalent. 9 does not equal 81, so these two ratios are non-equivalent. Let's look at an application question. Phantom Meadow Middle School has 86 7th and 8th graders, so 86 students, and 5 teachers. Chambersburg Area Middle School has 250 7th and 8th graders, so that's 250 students, and 12 teachers. We want to know, do we have equivalent student to teacher ratios? So we can reduce this, or we can use cross products. 86 times 12 and 86 times 12 is 1,032. So this cross product is equal to 1,032. And 250 5 times, I know that 4 250s gives us 1,000. So this would be 1,250 for this cross product. 250 times 5 is 1,250. So do we have equivalent student to teacher ratios? No, they are non-equivalent. Let's look at a banking application. So Keith deposited $2,000, so he made a $2,000 deposit, and he has been given $120 in interest. Jess deposited $11,000, so she deposited more money, and she got $660 in interest. Notice when I'm setting these up, I am setting them up in a consistent way. Deposit to interest, deposit to interest. I would like you to determine on your own whether you think these represent equivalent or non-equivalent ratios, and we will discuss that tomorrow in class. So we're going to review. A relationship represents a relationship, ratios represent a relationship between two things. Equivalent ratios represent the same relationship. And when two ratios are equivalent, they are called a proportion. We have two strategies for deciding whether two ratios are equivalent or not. And the two strategies are, we could reduce the ratios to determine whether they have equal values in simplest form, Or we can calculate the cross products, because if two ratios are equivalent, then they will have those equal cross products.